Good day. This is Wayne Potts, and this is section 1 of the sexual selection lecture. Now, why did Darwin say, just the sight of a peacock makes me sick? Well, let's look at this video and see if we can see what it was that bothered Darwin. I don't know if that shimmer has special significance. It might be just getting the wrinkles out of the beautiful train display. Okay, quite remarkable. Can anybody think why Darwin got sick? Well, he said this because a peacock's tail was at odds with his theory of evolution by natural selection. For which one of the following reasons? The tail attracted predators and hindered the peacock's ability to escape. It predicted that females should be the prettier sex. The tail made males worse at fighting each other. The tail made it difficult to mate. Or E, it disrupted social cohesion as captured by this Gary Larson cartoon where we have two peahens in a bar and a peacock over here displaying, and one peahen says to the other, "Don't encourage him, Sylvia." All right, well, the answer is A. The tail, this extreme tail, would attract predators and it would hinder the ability of the peacock to escape and therefore would diminish the probability of survival. And so Darwin's answer to this problem that's plagued him for a long time was his theory of sexual selection. So how do you explain something this beautiful and this absurd? These characters certainly reduce the probability of survival. So our fundamental concept is that sexual selection is a component of natural selection involving differential mating success. Often, male success is measured by quantity and female success by quality. So, another clicker. What character defines the two sexes? You should be able to answer in a sentence. We discussed this in the sexual reproduction module, so it should be quite easy. The answer is that females have big gametes, males have small gametes. And much of what follows was started by this initial difference. So, a few terms. Secondary sexual characters equal characters found in one sex but not the other, thought to usually arise by sexual selection, which is selection resulting from differential mating success. Now, sexual selection initially depended on there being two different sexes with distinct gamete properties, females with large, nutritious eggs, males with small, mobile sperm. Well, we call this anisogamy. Isogamy is equal-sized gametes, anisogamy is unequal-sized gametes. Anisogamy caused female reproduction to be limited by the number of eggs they could produce, while males were limited by their access to females and their eggs. This dichotomy led to the evolution of typical sex roles. Males compete for access to females, whereas females are choosy when picking mates. Now, for species with parental care, the differential investment in offspring started by anisogamy often became intensified. Female mammalian gestation, nursing, and maternal care being the most extreme general case. Differential investment in offspring is the driving force for sex differences in behavior and morphology. So males usually have the greatest variance in mating success as shown in this figure, because females are only limited by the number of eggs they can produce, males limited by access to females. So in this example, females produce 2 or 3 or 4 offspring, while males can produce anywhere from 0 to 6 offspring. Now the variance can be much greater. For example, the average size of male elephant seal harems is 200. So here's the extreme variance in male reproductive success for the elephant seals. So females have hardly any variance. They usually produce 1 young, and a few of them don't produce any young, and so you get a peak like this. So all the female reproduction is here. By the way, this is in a population of 1,000 females, so there's our 1,000 females and 1,000 males. Okay, for the males, we remember the average harem size was 200. So here are the 5 males that have an average, each have an average harem size of 200. And here are the other 995 males that have 0 offspring. So an extreme variance in male reproductive success, which this leads to large size dimorphism. Here's the harem male and his harem of females. Males are around 4,500 pounds, 3 times larger than females. And it also leads to bloody fights over harem master rights. So here are 2 bull elephant seals going at each other, blood dripping down their necks. So avian mating systems with the most extreme variance in male reproductive success are also those that show the most extreme sexual dimorphism in secondary sexual characters, as shown in this slide for birds. So let's first define some terms. Monogamy is a mating system where there's 1 male and 1 female. Polygyny is where there's 1 male and 2 or more females. Polyandry is where there's 1 female and 2 or more males. So you can see here, polyandry is on this part of the x-axis, monogamy here in the center, and polygyny is over on the right side. A lek is just a specific kind of polygyny, so these 2 columns are both polygyny, and you can see that the most extreme dimorphism in these 4 characters, plumage, body mass, wing length, and tail length, is for the polygynous species. Now, importantly, in polyandrous species where access to males is limiting to females, because the males incubate and raise the chicks, this sex role reversal also reverses secondary sexual characters. So here in the polyandrous species, you can see that the dimorphism is where females have the larger mass, larger wing length dimorphism, and larger tail length dimorphism. So this is strong evidence of differential investment in offspring, which causes one sex to be limiting for the other, drives evolution of secondary sexual characters. So polygyny leads to sexual dimorphism in size, in weapons, and in coloration and displays, and many other characters. So the following 6 slides are species with remarkable sexual sexually dimorphic traits. So here's a male and female mandrill primate. Here is a anglerfish. We saw this lady here and her parasitizing mate who bites into her, and their blood systems fuse, and he degenerates and basically just becomes a sperm reservoir. Okay, here's a cock and hen pheasant found here in Utah. The African lion, the male's 420 pounds, the female's 280 pounds. Mr. and Mrs. Mandarin duck, an Asian duck. And orangutans. Orangutan males are twice the size of females. So this concludes section 1 of sexual selection.